In number 89 on page 743, we have an interesting situation because we have iron hydroxide that is dissociating in water. So as this dissociates, we get iron 3 plus ions and hydroxide ions. Remember, for most ice tables, when you're dealing with the dissolution of a salt, these two both begin at 0. But because we are in, for part A, we are in water, what do you know is the molar concentration of hydroxide in pure water with a pH of 7 at 25 degrees Celsius? It's 1.0 times 10 to the negative 7th. This one starts at 0, but this one does not because we're in water. And remember, water always is going to have a concentration of hydroxide. It's usually unimportant because usually the number is so small it's insignificant, but in this case, it now becomes significant. So now what will happen is this dissociates. This will still go up by x, but this one will now go up by 3x. And then you solve it that way. For part B, what's slightly different, same exact substance, but now instead of being water with a pH of 7, it's saying what if we're in a solution where the pH is 5? So if the pH equals 5, that means the pOH equals 9, which means that our OH minus concentration is 1 times 10 to the negative 9th molar. So now when you're plugging this in, this will be 1.0 times 10 to the negative 9th. Now that number is so small we can probably disregard it, but then this is still going to be plus 3x, and this is going to be plus x. And then in C, you can look at it and see that it's at pH of 11.